Okay, where are we? You about ready?
Yeah.
Is it set on video? I haven't...
It's recording.
It's recording. Look at that. He's good. Okay. Here's the 3.5 millimeter TRS connector. So there's the tip. Here's the ring. There's the sleeve. There's the connection for the sleeve, the connection for the tip, and the connection for the ring. I'll talk about it more when we look at the actual connector itself. And then we're going to run this to two XLRs, two male XLRs. So the idea is this is going to be a stereo signal, like a headphone. It'll be the headphone connector, like for your computer or for your phones. So the wiring for a TRS connector, 3.5 millimeter or 1/4 inch, is the tip is the left channel's positive, the ring is the right channel's positive, and the sleeve is the ground. Okay, so left, right, ground. So we have the type of cable we're using is a double audio coax. So there's two cables. So here I drew the shield for one of the cables, and then the shield for the other cable. So there's two actual cables, and then there's a center conductor, which is the coax. You see, I kind of made it look like a coax on this end. So you have the center conductor. So one of them is going to be for the left channel, the other is going to be for the right. So we'll take pin 2, the hot. I'll talk about this more in a second. For the left channel, and we'll run it right to the tip. The tip, how you can tell in a connector, is there's a post in the middle where you see the contact comes over and out where you can solder. That goes all the way through the inside to the center. Then the ring, it just slips by, literally, it's really close. And then there's like a bar inside that comes over and then touches the ring. And of course the ground is the whole body of it. Now, since we have two unbalanced signals, remember we talked about balanced to unbalanced, all this wiring a few weeks ago. We got two unbalanced signals going into two balanced inputs. So on this one, we're going to float the ground. We're going to do that floating output. And we're not going to tie anything to pin 1. So we won't tie these two grounds together. And so the shield will be going to pin 3. So this will go into a true balanced device. It's just going to be looking at the difference between pin 2 and 3. And pin 3 will be holding steady, but still it'll get the difference between the two. So pin 3, the shield, will solder to here. And likewise, this pin 3 will come over through the shield and solder to the same place in the bottom of the main body of the connector. And there we go. Now let me come on around closer here, and here's where you're going to really need to zoom in, because this is really hard to see, and I'll hand this around. Here's the connector. Now right in here is where we really need to, you're going to have to pinch it and go in close, and probably still won't see. But the tip, I'm trying to get an angle here. The tip, you see that's like a post, and there's a right angle, L-shaped piece of metal. So that's the connection for the tip, where you're going to solder. The ring is right here, and you could barely see a little thin black insulation between the ring and the tip. It's not much of a gap. So I suggest you do not put a big, huge blob of solder on that ring, because it would be super easy to just blob that all together, and you got mono connection at that point. Left and right will be shorted together in a way that's not good. And where we're going to solder the ground, because this is a little different. This connector, I can't do it the way I'd like to do it, but we're going to solder the ground on the inside right here. So you see I already had tinned that. We're not going to bring it along the back. There's just not room to do it. A couple other things. Now, you guys can see that on that connector here. I'm going to go ahead and hand this around, but have a look you'll see that you have to look really carefully on that little black insulation. Now the rest of the connector, there's two things about this. Inside, there's going to be this little plastic thing that's real easy to lose, and I caught it. That slides over the connector. I can't do it right now because it's not folded, and you'll just put this over the wire. But this part, this is made because we got this double. Here's this double coax. This connector has a small rubber hole in the rubber for the. This is the strain relief. You just can't. I cut this open a little bigger, and it still is really hard to push this wire through. And then when you go to put the connector on, everything wants to spin. It's just not going to work well. As much as I love to have a good strain relief, I think it's going to be more of a problem. So what you can do is you can literally pull on this and take this whole thing out.
Can you just
and then just
like
put this on the cable.
make bigger the hole?
I did, but no, because
okay.
it still constricts too much.
Can you do this end first and then slide the
Even if you
the
like,
rubber thing on
if
from
you
the other
warm
side?
it, make it
No,
hard,
once
it
you won't be able to get it on. Trust me, you won't.
Because you'd have to slide it all the way up. and
Well, you
you'd
could.
get
It'd be
stuck.
hard to do if you did the other end.
Yeah.
But then trying to get this
See inside of it, yeah.
back inside of it is just not going
Oh
to
yeah,
happen.
well you're already around the wire. I
Because
see.
believe me, try it when you do yours. I took the diagonal cutters. Where are my diagonal cutters? See, somebody borrowed it in the last class and put my personal ones over on the shelf. Are those it? No, those not. That's not the ones.
You got the flat ones, right? You don't like these
Stop
the Yeah.
video.
Helio.
Okay, where were we? And I just went like this with the diagonal cutters and cut it a little bit bigger, you know, and that still wasn't good enough.
But if you melt it, like if you get it
No,
hard-
because the thing is this constricts in here, and this is just really, I mean, it's really tight. Right now, it's not too horrible because it's not in there.
okay.
And it still is, still push it. But once you get it in here, try it on yours. Cut out the back of it a little bit, and while it's still in there, and you'll see how really hard it is to slide this thing down. And then remember, you got to screw this on. You got to twist it. And it just you got to hold it really tight, and yeah, it's going to make a mess. It's going to make it where you're going to break the wire. So I'll slide this on. I'll slide this clear sleeve on. That fits pretty good. I mean, it slides pretty easily. Okay. But I guess let's pause for a minute on the, no, don't pause that. With this connector, and go to the XLR on the other side. These Neutrik connectors are really cool. I'll well, yeah, I can show you right now since I have it here. They're in 3 pieces. By the way, you take these bags, there's a little perforation that goes whoop, and it zips right open. And you got, oh, come on, get out of there. Got 3 pieces. 4 pieces. I learned to count eventually. 1, 2, 3, 4. Yeah. You don't have to remember to put this on. That's the great thing about an XLR, a Neutrik XLR. Obviously, the insert. But this one you don't have to remember to put on because there's a slit in it. There's an opening. This is the only part you have to remember to put on onto the wire. Otherwise, like this one here, this is I already did in the last class. You see, you slide the connector on, you solder this on, you take this part and you just press the slit like that. Press it through the slit. The XLR connector, that's the top of it. There's a groove on the inside, and there's a little square, it's hard to see, but there's a little square protruding thing there. So you line this up to the top, and then this will go in. And usually you can push it with the cable. If not, you can take needle nose or a screwdriver and push it all the way in. You slide this. Again, this has into that groove. It has a plastic part that goes into that same slot. So I had it hooked up on the bottom there. Come on. There we go. And then you take the back and you just screw it in. It's going to click, 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 click. A little more. I have taken this off so the clicks aren't quite as good, but you'll hear yours clicking. And it kind of holds it in there a little bit, and it's a great connector. And you can take it apart. It's a lovely, lovely thing. What I did here was on the webbing, all you got to do is take a pair of diagonal cutters and cut in between, like the webbing in between these two coaxes, and then this comes apart. You pull it. And that's what I had done here. Pulled that to separate this up. Okay, so now it's just like a regular XLR. The rest of the way. And remember, we're just doing pin 2 and 3, so you got to remember where pin 1 is. Okay, 1 is to my right in this case. Well, I want to do it upside down, so it's to my left. Because I like filling up the cups that way. And we're going to strip this about, remember, about an inch, which is what, 2.5 centimeters? 2.45, I think?
I think so.
Or 2.54? Can't remember the, I think it's 25.4, so I think that's the factor. And this stuff is really strong. You see me working on this pretty hard. This is amazingly strong for some reason, this wire. Look, it still is not cutting. There we go. And we'll get the shield. It's a spiral wrap. All get every single strand. I'm just going to twist this a little together to hold it together. Now this white inner core of this coax is really easy. Excuse me, really easy to like cut the whole thing when you strip it. I did it a whole bunch of times last class. It's not easy to strip. Okay, I got just a little bit of it, but it's fine. That's going to back off as I tin it. It's going to go. So let me tin this. Had the iron on from the last class. Hold on. How's the video going?
Very good.
All right. Okay. Bead of solder onto the wire, and then make sure the wire itself melts the solder. And see how that backed off? It looks like a decent length. And then this I don't have to go, oh, there's one loose wire, but it's right. I'm going to be cutting a lot of this off. I don't have to go all the way up to the end, and I don't have to go all the way down to the bottom. Oops, what did I do? Oh, that was bad. How did I drip that off? Wow. Okay. Fixed. I hope. You will see. Okay, now time for filling here. Clean the iron, tin, good bead of solder. I'm going to put the bead of solder underneath the cup. Well, that's pin 1. I don't need pin 1. Underneath, and then put the solder on the inside and fill it up. Really fill it up. Okay. Make sure you got the bead of solder touching, and put this on the inside. And see, it's not going too quick because I don't have a big enough bead of solder. There we go. Now I got enough of a bead of solder. I fill it right up. That should be, yeah, that's pin 1. So I'm only doing pin 2 and 3. Okay, so now the hot will go to pin 2. So we'll heat up, I'll do the hot first. We'll heat up pin 2 and lay this along the bottom and stick it all the way up into the insulation. And you wait, and you wait, and you wait. And on this one, you wait longer. Because what I noticed is this white insulation gets very soft with heat. And if I start bending this around to put the strain relief, it'll come apart and come off of the wire. So let it cool off for a while. You can kind of see if you move it and it doesn't look like the white plastic is going to melt off, then it's steady enough. Okay, so now I'm going to do the strain relief, and I'm going to guess at about this long. All right, the pin's still hot. Yeah, about that long. So I'm going to cut that off. Find the iron again. I'm going to try to do this. I'm going to do this right-handed here.
Are you left-handed?
Yes.
Oh, me too.
All great people are, right?
Right.
Okay, reheat. Make sure I got a bead of solder on there for the heat transfer. And this I'd wait a little extra long.
I've heard that a disproportionate number of U.S. presidents are left-handed.
I've never seen the stat on that one. So we got a strain relief. The hot is wraps around so that it won't be pulling on that, and we'll be pulling on the ground. And hopefully I didn't mess up the other part too much. Yeah, I think I'm okay. Then let's put the rest of this connector together. Slide this little bushing thingy here, and that just goes on there, just like that, see? And then we can take this part and slide that right in there. See, I'm used to seeing that slot sticking up, so I know what the top of the connector is. And then away we go here. Click, click, click.
What's the clicking?
It's literally like a ratchet, and it keeps
yeah,
it from
that's
coming
what I
off.
thought.
Yeah. And so these are good. I mean, they're still pretty robust connectors. I mean, you can step on this a little bit, but you can actually break this plastic part if you step on it more directly.
What happens if you want to take it apart? Is it possible to
Yeah.
ratchet it the other
You
way?
I've taken this one apart a few ways, and it gets a little less ratchety the more you do it.
I see.
Yeah. So, but it's not. I've never seen it be a problem either way. Okay, that's the easy part. So we got the two males over there. Now, this connector, the 3.5 millimeter. We got to tin these first. Now I'm going to do a quick job of tinning because these are already tinned. I've already soldered on this connector. So at the moment, this is a used connector. Remember, bead of solder for heat transfer. I'm going to put the soldering iron on the outside. Let me see if I can turn this a little more this way. On the outside and solder on the inside.
Yeah.
See how that solder went whoop, down to the center pin? I don't want that to happen on this side, so I'm going to be really quick. Okay, because I've already tinned it, because I don't want that to be all one big puddle. Then, bead of solder. I'm going to go underneath, and I'm going to fill this part up with solder. Like I said, I've already tinned it, so there already was some solder in there. So right under there is where we're going to solder the ground. And here's where prepping the cable is going to be tough. Yeah, we're still good. We're still good there. I would love to have this strain relief squeezed down on these outer black conductors, but that's just not going to happen. It's just not enough room. We can't deal with, it's too tight to deal with the shield in there. So sometimes you have to adjust to what's in front of you and what you can do and what you can make the best cable you can make. And yeah, I suggest on these, when you guys use these cables, whenever you plug these in and out, grab it from the connector, don't pull from the cable. You shouldn't do that anyways. But especially with this one. So I'm going to strip these back to probably about here. Because I have to. So Yeah, okay, where's the center conductor here? I usually like to get my thumbnail right about there. And I probably should try to use razor blades, but I'm stubborn.
Would razor blades be better for this?
Yeah, probably. But you have to be very gentle with it. Don't go too deep because this is not very thick, this outer black. I mean, it's thick enough. But,
Is the razor blades in that dish even sharp?
oh, yeah, they're going to be sharp. Most of them will be.
Hmm.
Some of the rusty ones might not be.
Maybe not.
Come on. See how I leverage with my thumb when I do this? And I hold the wire with the other fingers. And I can get a lot of leverage that way. Okay, so we got the two cores here. All right, I'll just quickly twist them together a little bit here. And every strand, put it off at a right angle. Now, these are going to want to put these together, but I don't want to have to twist this, so I got to study this a little better. Look at the cable. One side is marked, dashes, and then there's some writing, Mogami. One side is plain. That's going to be your cue for one of these is left channel, the other is the right channel. You choose. But since I'm left-handed, I want the one marked to be the left.
There you go.
Right? And left is the tip of the connector. So the tip of the connector here is over to, coincidental, it's on sort of on the left of this connector at the moment. So actually this is good. If it was like this, I would pull the shields around. But this is wanting to sit just like this, so that's great. So I'm going to take, because that's the left and that's the right, so I'm going to take the two shields and twist them together on this side of the pair of coax cables versus this side. I could have done it, you see. And you got to think ahead. The other thing now is this shield is going to take a bend and come over. It's going to bend, it's going to come down and go over. So I want to kind of do this ahead of time, all right? So that I kind of have an idea about how far. So actually while I'm here, I'm going to go ahead and tin this. I'll usually tin everything together. If you be efficient, you should only pick up tools and do as much as you can with one tool. I don't have to go all the way to the end. Come on, see I have a bead of solder. Okay, now it's heating up. I let the work do it here and I just dab. Come on, dab. Don't go too fast or too slow. Follow a little along. Okay, that should be good. So I sort of pre-bent it a little bit. Don't go too close to the coax because it's gonna melt. Oh, I might have already done that. Worked fine the other class now. The other class I did not have an issue. Because this one, when I'm filming it, I'm probably gonna have an issue. Okay. It'll be all shorted. Now I'm gonna see, ta-da, it's all gone. There we go. And you see, I just did a little bit. Don't need much. It should sit nicely there. Dirty, but I'm away from the sponge. And so we're just gonna, I always gotta find the bead of solder on your iron. And add a little more flux. Oops, did I actually do it? Yep. Let the wire heat up. See how it backed off? Now it's all nice and backed off. And let me see what I got here. Now these are going to be too long, which is fine. You backed off, now I'm going to trim it. You notice I put my finger behind it? He flinched here, but for good reason. If you, I covered it up so when the cuttings won't go flying. So be careful of that, because you go cut like this, it goes flying. So always be aware of it. And I always try to pick up the pieces. It comes from working around electronics and consoles and stuff like that. Little bits of solder flying around is not recommended, in case you don't realize that. One of them is a little too long, but it's all right. What you're going to have to be careful of, by the way, is not to take the right channel and stick this wire too far in, because then it can end up shorting to the tip again. So you got to be careful. And now I got control over this. I'm going to do the hot and the cold first. I mean, the left and the right first, the two hots. We'll do the ground afterwards. Clean the iron here. Try not to burn myself. I guess let me do this side first. I'm going to put the wire on the inside. You notice how I got my finger here steadying myself against the vise. And heat up the outside. When it melts, it goes. Say, ta-da! Come from above, or maybe you can. You can't. I'll try to go from below here.
That's enough of me.
Okay, so I'll position the wire. Make sure you can get the wire in the right position before you start. I get the position wire on the inside. Now I'm going to heat up this part. I'm not getting a good. There we go. There we go. I think that's good. I'm a little far away from it. I'm on kind of on the top of it, but that's close enough.
Just got a nice.
Yeah, I'll take some more pictures, I guess, later. Now, I'm going to pull this up, see, and put this down here and see about how long. We got to cut this to the right length. I'm gonna put a little strain relief. You have a little bit of room to put a tiny bit of strain relief. So it probably needs about there. Now this would go flying. Cover it up. I'm going to show you. You're going to see it fly. See? Yeah. So I'm gonna. I guess my hands use this. I'm gonna make sure I got a little bit of strain relief here, and that's in a good spot. So iron. Now this has to heat up that whole big connector, so make sure you got a bead of solder. We don't need more solder. We got plenty of solder to make the connection. But what we need is the heat transfer. Heat it up, and you see it melt on the top, and boom, we're done. Do it quickly. Hold still. Now, I wouldn't recommend to tighten this down too tight. Okay, I'm sure it's cool enough. I'm going to tighten down these strain reliefs. Start bending it. Just because you got to get it out of the way to put the connector together. But I really don't want to have this holding it too tightly, because you'll cut through. I might have done it too tight already. You'll cut through it, but that's about the best I'm going to do, I think. Let's see. Now, we'll slide this clear tubing over. It should be able to get this over. I didn't make it too big. It worked perfect the last class. Not this time. I can see where it's a little messed up. Oh, come on. Oh, come on. to look to see where it's binding it, and that I think was it. There we go. Now I got it slid on there. Insulation. Pull this up. Slide that over. Come on, hold it. There we go. Let's get the thread started. There we go. And ta-da. Like I said, I wouldn't go pulling it from this much. I'd grab the connector here. So now, the test, the ultimate test. You gotta test the cable. So I'm gonna put it on continuity. Test that it works. It works. I'm gonna put the connectors somewhere here. I don't want to be able to get one anyways. Well, maybe, actually, let me try. Kind of worked. Okay, I'm going to check for shorts first. I'm going to hold this connector down with some fingers here and then go between the sleeve and the tip and ring and tip to ring. Ooh, that's promising. I'm surprised. I think it might be good. I'm supposed to be confident, right? Okay, I'm going to hold to the shield. Both pin 1s. I mean, pin 3s. There we go. Remember, we did ground to pin 3. I'm so used to going to pin 1. Both pin 3s. Good. Now I'm going to go to the ring. We'll go to pin 2 of, well, I can't see which one is the, which one is the dots?
The bottom one is the left.
Okay, so this should go to pin 2 here. It's the right channel. The ring is right. Ring right. And then this one should be the tip. Voila. We're good.
Yeah.
Should work.
This is gonna like fade out.
Hey, don't get too artistic. It's for YouTube.
Yeah.
Okay, thanks.